Hello everyone, welcome to my chemistry channel B.L.DASH, short and sweet in chemistry. Now I am going to explain the chapter electrochemistry, that is short revision in electrochemistry. And here the topic is dependence of the concentration or dependence of EMF on concentration. Then how EMF depend on concentration of electrolyte and temperature. That means this is called Nernst equation. Nernst equation means the EMF, how it depend on the concentration and temperature. This part is 10A and class 12th, and here 10B. I will explain the continuation of the Nernst equation also. The electrode potential of electrode and EMF under standard condition. You know, standard condition means it should be related with the standard electrode potential and standard electrode potential of the cell also. So here the concentration of the half cell. You know, in electrochemical cell there are two half cell, and each one, that one is known as cathode and anode respectively, and here the concentration should be 1 m and temperature should be 298 Kelvin. So Nernst, one scientist who gave a relationship between that electrode potential and concentration of the electrolyte solution, and two half cell, each electrode potential and concentration should be known, and that formula, that equation, that is called Nernst equation. General reaction, if you say how it gain electron and changes to solid. Let M here n electron, that is plus n. If it takes n electron, then it gives M. And suppose it is M plus 2, then what you will do? Plus 2 electron. 2 electrons should be accepted. And then now equation, what he say, that E mean here electro potential of the cell, that is equal to half cell, or that is equal to E0, standard electrode potential. And here RT, R is called gas constant, N is the number of electrons which involve, and here N is the number of electron, Ln means 2.303 into log. And M solid concentration, M solid means the solid concentration always taken is 1, and by M n plus, that means number of electron, and that is aqueous solution, electrolyte solution. So if you take one electrode, half cell say, and that is M plus n by M, so what you will write? M n plus by M, that is equal to E0. E0 means standard electrode potential of that electrode, and minus, if you Ln changes to log, then what is the value? 2.303 by NF, and here RT, and log, instead of Ln you will put log, and here M concentration, solid concentration, M n plus aqueous concentration. So solid, that is taken as 1, and here the concentration should be given in electrolyte solution. And where M n plus by M electrode potential, and 0, that is standard electrode potential, and that is solution 1m, and here it is 1m. And are the gas constant, the value should be, one should remember this one, 8.314 joules per Kelvin mole inverse. And so here this is R is the gas constant, that 8.314 J K inverse mole inverse. And temperature, that is 298 Kelvin, and F equal to, what is F? F is the farad of electricity. You know the value 96500 coulomb. And N is the number of electrons gained during electrode reaction. And what is the N? N is the number of electrons gained during electrode reaction. What is the number of electron it is gained or accepted that reaction takes place? M plus N, molar concentration of ion M solid, and that is molar concentration of metal solid, that is taken as 1. And here if you write here correctly in explain properly, then E0 here, that is equal to E M plus N by M, that electrode potential of that cell, half cell, or here E0, standard electrode potential of that electrode. Which electrode? M plus N by M. And here minus, the value will put 2.303, 8.314, 2 into 298. Remember, these 3 multiplication gives a constant value. Instead of writing this long value, simply you write here 0.0591. And here this is in terms of here by N. N means number of electron. And when divided, 2.30, 8.314 into 298 divided by 96500, you will get this value. Log 1 by M N plus aqua concentration. Then why? Because MS value, that concentration of a metal solid, is the 1. So E equal to, that means E equal to what happened? Shortly, E electrode potential, the standard electrode potential, minus 0.591 and divided by N, and what? Number of electrons. Log 1 by M N plus the concentration, that should be in bracket, molar concentration should be known or should be asked. Then what happened? You only observe what is given, what is asking at 25 degrees centigrade, that is 298 Kelvin. So here example, calculate the potential of the zinc electrode. Zinc electrode, or can say zinc electrode, in which the zinc ion actively that concentration is 0.001 M. M should be written. And here E0 Zn plus Zn, it is given also in question, that is minus 0.76 voltage. Then what it is given in the question? One is molar concentration given, one is E0 value of the zinc is also given. You can see in this equation what is given. Here E0 given and here this value given. And what is asking? Asking is E. Calculate potential of the electrode. Potential, not standard. Standard is value is given. Standard potential is given. And only cell potential, or you can say the potential of this electrode that E is asking. So what happened here? R value you know, and F value you know, and Zn as release 2 electron or lose 2 electron, it changes to Zn plus 2 aqua. And here what happens? The equation, first equation you should put here, E equal to E0 minus 0.0591 and 2 by 2. By 2 mean where N is E, N is the number of electron. Log 1 by Zn plus 2. Zn plus 2, that molar concentration is given here, and here value E0 is given. Then you can calculate easily, and here minus 0.76 voltage, and you put all the value minus 0.0591 voltage here by 2 log 1 by 0.001. So what happened here? You can calculate and lastly answer is minus and 0.8485 voltage. That means E Zn plus 2 by Zn, here E cell, not E0, remember, cell potential or electrode of the cell, that means potential of the cell, or you can say cell potential of this electrode, the value is 0.8485 voltage. This is the one question. Then application of Nernst. Wow, what are the main application of Nernst equation? If you know all the value except cell potential, you can calculate the cell potential. Calculate the cell potential using Nernst equation. Daniel cell, let us say Daniel cell, zinc oblique Zn plus 2 and Cu plus 2 oblique, that is Cu. So here what happened? This should not be double sign. This should be one single, because double sign what indicates? This indicates that is salt bridge. So here what happened? This is known as salt bridge, and this is only cell here, which part is losing electron, which part is gaining electron, that is electrode. And here cathode, which is cathode? Cathode, remember, in any cell representation, the left side is anode, whereas right side is cathode. So cathode, that means Cu plus 2 Cu. How can calculate? You put the formula according to Nernst equation. You put E0, that is standard value of electrode, copper electrode, minus RT by 2A, because here 2 electrons involved. What is the sign 2 plus? That means 2 electron. Remember, 2 plus means 2 electrons. So it is the value 2F. Then here ln and divided by, this is a common formula where you can put also 0.0591. Okay, now you can see anode also you can put electrode potential of zinc, that is equal to standard electrode potential of zinc minus RT by 2A, because 2 means number of electrons, because it is here 2 plus, so it is 2 plus, and here Zn plus 2, and this is the formula according to Nernst equation. In Daniel cell, N is 2 and cell potential EMF of the cell you will calculate. So what you will do? The cathode minus anode. Here for cathode you will write a long equation minus another equation. So what to do? Before that, before just now I told what is electrode potential of copper. That means that is equal to this value minus RT by all the things given just now. So you make a minus E0 value, E value what is there, and E value of Zn there, and you take both, subtract each. That is zinc electrode potential, you make subtraction from copper, because copper is act as a cathode, so cathode should be first minus that anode. So when you calculate this, is the value comes E0 means standard electrode potential of copper minus standard electrode potential of zinc. That you make a minus, so you put in bracket minus RT by 2F, because this is the formula, and ln 1 by Cu plus 2 aqueous, and here then ln 1 by Zn plus 2 aqueous. Both molar concentration you will put here. Here you will put both molar concentration according to question. And here otherwise, when you put the value of R, T and F, then all the value you put and calculate. This is the value I already told also. E0 cell, E equal to E0 cell. E0 cell means standard electrode potential of the cell. Just now you see, you subtract zinc electrode, that is standard electrode potential, from copper electrode potential, standard electrode potential, then you will get the value E0 cell means standard electrode potential of the cell minus 0.8485 0.0591, that what I told, after putting all the values, this will come. And here what to do, RT value, if you put RT and F value, then you will get that one. That one is 0.059, sorry, you will get 0.0591 by 2, because 2 is the number of electrons. So example 2, where cell representation is there, that means from cell representation you think your cell, which one should be cathode, which one should be anode. Now the cell representation, this one as left side cathode and this one is right side, that is anode. And so cell reaction is, what is the cell reaction? That is nickel loses electron and Ag+1 gain electron. So since there is nickel, that is 2 electron that is losing, that is why Ag plus gain 2 electron. Also, when you cancel each other by multiplying by 2, then what is the value? Ni bracket S, Sy, because it is solid. And here 2 Ag plus, because 2 electron, 1 electron required for Ag plus, 2 electron required for 2 electron to equate the electron. So here E cell equal to E0 cell. E cell means cell potential of the cell or electrode potential of the cell equal to E0 cell means standard electrode potential of the cell. Cell means which is given. Cell is nickel oblique Ni+2 salt bridge Ag+1 oblique Ag. Then here that Ln RT, general equation. First you see general equation, and minus RT by Nf. N is the number of electron 2. So Ln Ni+2 molar concentration divided by Ag+1, that is whole 2. What is indicate? What here indicates? That means nickel, which is cathode, and silver, which is anode. So for general electrochemical series, you know AA plus BB, and where it is using an electron, then what happens here? CC plus DD, that is a product in electrochemical series. This is the reactant, this is the product, and how many electrons involved? An electron. So E cell, according to formula, E cell equal to E standard. E means standard electrode potential here, minus RT by Nf and Ln. The upper part you can see Ni+2 molar concentration divided by Ag+1 molar concentration. And why it is multiplying by 2? Because in overall reaction 2 is multiplied by Ag+1. That means this part, Ni+2 molar concentration divided by Ag+1 whole 2 concentration, and that is called Q. That is equilibrium at instant. So what happened? You can write, if it is the reaction what is given here, A plus BB, that is equal to CC DD plus DD. Here you should write what is Q here. You learn from 11th class. Sorry. E cell equal to E0 cell minus RT by Nf according to the Nernst equation you are proceeding. But Ln Q, instead of Q, you can write here C to the molar concentration to the power C, D molar concentration to the power, that is D, and divided by A molar concentration A, B molar concentration B. That means here, you remember your 11th class, the equilibrium chapter, and that is called equilibrium constant. So first you making Eg, then you will put that Kc value. E cell mean, again I am telling, E cell mean electrode potential of the cell equal to electrode potential, not standard electrode potential of the cell, minus 0.0591, you can put 1 or not, and here by n, that means log C to all the things above that you put here, C molar concentration to the power C, D to the power D, A here A power, B here B power. That means how we will put that value later we will see. First we will see what is the representation of the following cell with EMF. You know here, magnesium solid, this is given. The overall reaction is given. Then how can you represent the cell? Magnesium solid plus 2Ag plus 2Y2, that means there should be 2 electron involved for Ag plus 2 Ag becomes 2 Ag. That is why to equate the electron, accordingly you remember and you think yourself, what is it 2? 2 is multiplied by Ag plus, that means Ag plus gain 1 electron to change to Ag. To equate the number of electron, 2 is multiplied here. Now we will see representation of the following cell with EMF. EMF is given, and then what is the cell representation? E0 cell, standard electrode potential of the cell given, and you can see here Mg solid plus 2Ag plus 1 having concentration 0.0001 m, and here it gives Mg plus 2 0.130 m and plus 2 Ags. First question, why it is multiplied by 2? That means here Mg loses 2 electron, N means 2, and here that is why, and Ag plus 1 gives Ag, that means it accepts the gain 1 electron. That means the first line, that is 2 electrons, second line it is 1 electron. How to equate? If you multiply the half cell Ag plus 1 to gives Ag by 2, then the equation that cell reaction is completed. Then how represent the cell? From this equation, you can see silver plus 1 gain electron to Ag, reduction takes place, that means react as cathode. And Mg, where loses electron, Mg gives Mg plus 2, that means it is oxidation, that is anode. So the cell, how can you represent? The left side is cathode, right side is anode. So Ag plus oblique Ag, that is cathode, and Mg plus 2 oblique Mg, that is anode. And here you can see the standard electrode potential. Standard electrode potential means here it is given. What is that value? 3.17. So 0, if it is 0, E0 means standard electrode potential. E cell means that only cell potential. Then next is, how can you write the E cell according to Nernst equation? E0, E cell, electrode potential of the cell, that is called cell potential, equal to E0 cell, standard electrode potential of the cell, the value is given, minus RT by 2F. I told also instead of RT by F, we can put 0.0591, that means here N equal to 2. So this is the Nernst equation, E cell equal to E0 cell minus RT by 2F ln Mg plus 2 concentration by Ag plus 1 concentration. So you put the value here, all the values, standard electrode potential 3.17 and N equal to 2, and that magnesium concentration and silver concentration already there. By calculating, by simple calculation, you get the value 2.9 voltage, that E cell means cell potential, electrode potential of the cell. There is no word standard here, equal to 2.9 voltage. That means there are two processes. One, simply the electrode potential given, value given, you make a minus, or you can by using by Nernst equation where the concentration is given, temperature given, then you should calculate generally temperature to 98 Kelvin. So here you put all the values. After that you will get the electrode potential of the cell or cell potential, and here after that you will see how the equilibrium constant is used. When using Nernst equation, by putting all the concentration, the last side, the concentration divided by concentration of the reactant product, that is termed as equilibrium constant. In 10th B part, we will see how the Nernst equation is related to the equilibrium constant, Kc. Thanks for watching my video. I am XPGT Chemistry KVS. Please subscribe my channel Short and Sweet in Chemistry B.L.DASH. Thanks again to all.